Hello students, last class we learned about the relation between the coefficients and the roots. Today's class we will learn about quadratic functions. In simple words, if we plot this value in a graph, what would it look like? Okay, to find that we will do little derivation over here. So this is written, it's function of x. This means the value of fx totally depends on the value of x over here. So I can write f of x equals to, which is given, ax square plus bx plus c, right? Now if I take a common, what I'm gonna get, I will get x square plus b by a into x plus c by a. Now we will do little more adjustment over here so that it looks like a particular equation. Okay, so what I'm gonna do is, if I write x plus b by 2a whole square, now what will happen? Now see, what is x plus b by 2a whole square? It is x square plus b square by 4a square plus 2 into x into b by 2a, which is basically bx by a. Now see, x square we already have an x square over here, b by a into x we have it. So the extra thing that we have added over here is b square by 4a square. So what we'll have to do, we will have to subtract b square minus 4a square so that the total thing remains the same. So what can we write here? So we subtracted b square by 4a square. Now we already have another term, that is plus c by a. Now if we simplify it a little bit, what will it look like? We will get a, this part we have x plus b by 2 whole square, and if we take LCM over here, what we will get, it's 4a square. It will become b square minus 4ac. Now do you remember what do we call the b square minus 4ac? That's the discriminant, which is denoted by delta. So b square minus 4ac. So what we're going to do is, in place of delta we're going to write, okay, so we will get a, in bracket we will have x plus b by 2 whole square minus delta divided by 4a square. What is what? That is function of x. Now function of x, we can take it as y. Now if we simplify it a little bit further, if we multiply the a, it will become a into x plus b by 2a whole square minus delta divided by 4a. If we bring the delta by 4a on the other side, it will be y plus delta divided by 4a, which is equals to a into x plus b by 2a whole square. So this is the equation of a parabola. So what we understood, just like in 10th standard we learned what's the equation of a straight line, y equals to mx plus c. So this particular equation represents a parabola. Okay, a parabola whose vertex will be what? Minus, the vertex will be minus b by 2a and minus delta divided by 4a. So we got that a quadratic equation represents a parabola whose vertex will be minus b by 2a and minus delta divided by 4a. So if any quadratic equation given, we know the values of b, a and delta, we can easily find what will be the vertex of the quadratic equation. Done. Now there are three case studies. The first one, it says when the delta is 0. So we already learned previously, when the discriminant is 0, what we got? We got the roots of the equations are real and equal. Okay, so delta is equals to 0, so the vertex, the delta part goes 0, so the only roots of the equations will be minus b by 2a and minus b by 2a. Since both the roots are equal, both will be minus b by 2a minus b by 2a. Now if we plot these values in an equation, for example, how we're going to put it, suppose we have this equation y equals to ax square plus bx plus c. So we will make a table. We'll see in the later part in equation. We'll write x over here, y. So we'll put some values of random values of x, suppose 0, 1, 2. Correspondingly, whatever value we will get for y, we'll write it over here. So we will plot these coordinates on the x and y axis, and then we will see what type of graphs do we get. Okay, so it said when the delta becomes 0, the vertex will be minus b by 2a minus b by 2a. That means you're going to get a graph which will look quite similar to this. Now see, both the graphs looks different. One is upward, one is downward. How do we find that? When the value of a, the coefficient of x square, is greater than 0, you will get a graph which will be upward. Now see, it says it has one root, right? So that root is what, this part where the graph is touching the x-axis, that is the root of the equation, which you can easily find by minus b by 2a. When we will get a negative value of a, that is a less than 0, your graph will look something like this, which will be a downward graph. Same, it will have the same roots, which will be minus b by 2. We'll understand this better in the questions. Case number 2 is when we have delta which is less than 0. So we already learned when the value of delta is less than 0, what do we get? Inside the root we get some negative number, maybe negative 30. That means what? This equation has no real roots. Okay? If it does not have any real roots, what will it look like? The graph will never touch the x-axis. Wherever the graph touches the x-axis, that is the root of the equation. Since this it has no real roots, so x will never be a real number. So in the x-axis, what do we put? We put only the values of x which are real numbers, right? Since it has no real roots, so the graph will look something like this. And the vertex of the graph, that you can easily find, that we already learned how we can get that. That's nothing but minus b by 2a minus delta by 4a. Now the graph will be upward or downward. How we can find that? We can easily find by looking at the value of a, that is coefficient of x square. If a is greater than 0, it will be upward. If a is less than 0, it will be downward. Done. Let's take one more case. The third case is when delta is greater than 0. So when the value of the discriminant is greater than 0, we know that it will have two real and distinct roots. Now look at the graph. It says two real and distinct roots. I told you wherever the graph meets the x-axis, those are the points where it will have roots. See, the graph is exactly meeting the x-axis at two particular specific points. So when you will get the value of delta which is greater than 0, you can see the graph will meet the x-axis at two particular points. Again, how we can find the vertex? Vertex finding is the same, minus b by 2a minus delta by 4a. Fine. Now in this case again, how do you know? How will you know if the graph will be upward or downward? We'll see the value of a. When the coefficient of x square is greater than a, we will say the graph will be upward. It is less than 0, we will say the graph will be downward. Done. So we have seen three case studies and we have learned that the quadratic equation gives a graph. It looks like a parabola. And how do we find the vertex of the parabola? That is easy. Minus b by 2a minus delta by 4a. B is the coefficient of x, a is the coefficient of x square, delta is the discriminant, that is b square minus 4ac, a is again the coefficient of x square. Then we learned about these three cases. When delta is 0, it will have only one root, both roots will be equal. The graph will touch the x-axis at one particular point, and what will be that point? Minus b by 2a. When the delta is less than 0, the graph will have no real roots. That means the graph will not be touching the x-axis. Third, we saw when the delta is greater than 0, the graph will touch the x-axis at two specific points. That means it will have two specific and distinct roots. Let's try one question and understand everything in details. Here they are saying draw the graph of the equation fx. So in place of fx, I'm going to write y. So y is function of x, which is given x square minus 5x plus 6. Okay, now what we'll have to do it over here? They're asking us draw the graph of this equation, right? So before that, what you're going to see, we will find out the value of delta. From the value of delta and the value of a, what can we decide? We will know what type of graph we will get. If delta is 0, then we will say it will touch the graph at one particular point. If delta greater than 0, it will touch the x-axis at 2 point. Less than 0, it will not be touching the x-axis. Now see, the value of a is 1, which is greater than 1. That means what? We will get a graph which will be upward facing. Now let's find the value of delta, which is what? B square minus 4ac. The value of b is minus 5, then minus 4, 1 into 6. So 25 minus 24, which is 1. See, by getting the value of delta is greater than 0, that means what? This graph will have two distinct roots. So can you did you get the idea? That means our graph will look something like this. It will be touching. Now we need to plot this graph on the coordinate axis. Before that, what are you going to do? We need some coordinate points, right? So we will easily find the coordinate points. Before that, we are going to find the vertex of the graph. We already learned how we can find the vertex of the graph. Let me plot some points. So first, what we will do in the equation, in place of x, we'll put 0, 1, 2, 3, 4, and whatever value we get for y, we're going to write it over here. From that, we'll get the coordinates. Okay, before that, let's do one part. We need to find the vertex of the graph, which is what? Minus b by 2a minus delta divided by 4a. So what's the value of b? b is minus 5 divided by 2a, a is 1, then we have minus delta value is 1, then we have 4 into 1. So what's the vertex we are getting? We are getting 5 by 2 comma minus 1 by 4. Let's write this somewhere. So we got the value of x as 5 by 2 and the value of y is minus 1 by 4. So we got the vertex. Now we need few more points which we can easily calculate. So let's take x equals to 0. So if you put the value of x into 0, what are you going to get? 0, 0, y will become 6. See, this is how we're going to get the coordinates of the graph. Okay. Now let's put x equals to 1. What we'll get? 1 minus 5 plus 6. So what will be the answer? 6 plus 1 is 7. 7 minus 5 is 2. So when x is 1, the value of the graph will be 2. Okay. Now let's take x equals to 2. So what we'll get? 2 square is 4. 2 5s are 10 plus 6. 6 plus 4, 10 minus 10. So when the value of the graph is 2, answer is 0. Let's take the value as 3. So 3 square will be 9. 3 5s are 15 plus 6. 6 plus 9 is 15 minus 15, again 0. See, these two values, the graph is exactly at the x-axis. That means these are the roots of the equation. Let's take few more points so the graph will look better. Let's take the value as 4. So what are we gonna get? 4 square is how much? 16. 5 fours are 20 plus 6. 6 plus 16 is 22. 22 minus 20 is 2. So when the value is 4, we're getting it 2. Let's take 5. 5 square is 25. 5 fives are 25 plus 6, 0. So when we're taking 5, the answer is coming as 6. Fine. So we got the values of the coordinates. Now we will plot the graph. Let me take a graph over here. Let me make it a little bigger. So we have values till 5. So I'll make it a little smaller. Yeah, now we have the values till 5. I'm going to directly plot the values over here. First we have 0 and 6. Okay, 6 is not visible. Let it make it smaller. Yes, now I think 6 is visible. So 0 and 6. This is the first coordinate. Next we have 1 comma 2. So 1 over here, 2 over here. Next we have 5 by 2. 5 by 2 is how much? 2 and a half. Okay, and it's minus 1 by 4. That means what? It's 0 to 1. It will be 1/4 of that. So that value will be here somewhere. Next is 2 comma 0. So 2 comma 0 will be this point. Next is 3 comma 0, which will be this point. Next we have 4 comma 2. 4 comma 2 will be somewhere here. Next we have 5 comma 6. See, we got all the points. Now if I join it, the points, how will it look? It's looking just like a parabola. The graph does not look much better, but this is how it is. Okay. Now we got the equation as a parabola. Now see what are they asking? Discuss the sign of x square minus 5x plus 6. This part is very important. So see, I'll write this coordinate. This is 2 comma 0. This is 3 comma 0. That is 4 comma 2. That is 5 comma 6. That is 0 comma 6. That was 1 comma 2, and this point was 5 by 2 minus 1 by 4. So we need to discuss the sign of x square minus 5x plus 6. Okay. Now what's over here? When the value, watch carefully at what point the value of y is 0. See, when the value is 2 and 3. So we'll write this equation will be equal to 0 when the value of x is either 2 or 3, right? We're getting 0. Now, when the equation is negative, so see, only for one coordinate we got the value of y as negative. So we will say this equation is less than 0, and for what point we got? See, here is the point 2, here is the point 3. So when we took something between 2 and 3, we got a negative value. So we will say this equation will be less than 0 when the value of x is greater than 2 and less than 3. I hope all of you understood. In the graph, if you see, only one point is there in the table for which we got a negative value of y. So this equation is what we wrote it in terms of y. So when we will take something greater than 2 and less than 3, see the graph is going below the x-axis. That means what? This side is the negative side of the graph. So when the value will be between 2 and 3, we will get the value as less than 0. Then see when we will get it greater than 0. Now see, for all other values, the values which are less than 2, these values are less than 2. Now look at these values. These values are what? Greater than 3. So when we took something which was less than 0, like you can see this part of the graph, it's on the positive side of y. See, all values of y are positive, 6, 2. When we took something greater than 3, after 3 we took, this side is also positive. See, 2 and 6. So we will say the y value will be positive when x will be less than 2, when we'll take something some value which is less than 2, and when we'll take some value which is greater than 3. So this is how we got the sign of the graph from the graph. I hope all of you understood this question. So this is how they will be asking a question. First, you're gonna find the coordinates. From here you're gonna easily find the vertex. You will plot the points over here. Looking at the graph, you can easily find these answers, like for what point it will be 0, what point the value of y will be less than 0, and for what point it's going to be greater than 0. Fine. So we have discussed about the function of quadratic functions. Okay, so if you have any doubts regarding these questions, you can ask me in the comments. Next class we'll take few more questions. So I'll see you students in the next class.